to change to some easier topics like statistical learning or supervised learning. For most of the cases, I think it will be very useful for our data analysis to prediction or classification different type of the task that we'll meet on daily basis, either for learning, the statistical learning, or to use in a real world scenario. They are quite useful. This is one of the I would say test I would do from every now and then. It's called comparing the models. As you can see, first of all, I show you a summary that usually when I compare the models, different models, first of all, I need to know the data. Today I'm going to show you the data set from the Kaggle. Is a credit card default data set. I know it is very intuitive. Most people use such data set to train a model to predict if the client is going to default next month. It's very useful, but the first step, you need to know the data. You need to know every column, what it means. I'm not going to show you here, just to keep the content as concise as possible. Second of all, you need to do standardization. You need to separate numerical and categorical data. So numerical data, you can calculate, just standardize to do not let the size or the sheer volume or the amount of a variable impact the model too much. About categorical variable, the common practice is to convert it to dummy variable. During my test this time, as you can see here, in the compute side, first of all, I count mainly the runtime of each model, how much runtime it will cost to train the model. So like the k-means neighbor, decision tree, random forest, and so on, I use a very simplified parameter setting, and most of the code are generated by ChatGPT. I already checked it. It seems good. I suggest you also to do this test because it will help you to understand how much compute each of the model will cost. Then about the complexity and the interpretability. For example, like complexity, ChatGPT gives me complexity. Is like a complexity measure. I have not yet 100% matched them to the very rigorous academic representation. But about the interpretability, I think it's quite accurate. For example, like a linear regression and logistic regression, you can interpret the change of the independent variable to the dependent variable quite easy. But about the neural network, I believe you already know that we have multiple layers of neuron. We have activation function. There are so many changes, so many detailed calculation inside the model. It will make it very hard to explain. And also for the transformers model, like the large language model, the structure is very complicated. We cannot easily interpret such model. And then if we are going to look at the number of parameters, you can see like a neural network has very, very large parameter sets. Of course, you can arbitrarily reduce the size of the number of parameters, but in any way, the runtime to get the similar results will be the highest for neural network. And for random forest and gradient boosting, you're going to have also much higher runtime relative to the simple like linear regression, logistic regression. Then, whenever you want to go deeper to analyze each model, I really suggest to get into the overfitting part first, because when you have this model, your objective is to catch the more generalized pattern to apply to the neural case, to the test data which you have never seen, the model has never seen. So whenever you use the existing data to do the train and the test data, to separate them and to fit them in the model, whenever you see that train accuracy is higher than test accuracy, note that the overfitting is present and you need to address it actively. Today's code, I'm not going to dive very deeper to the overfitting resolving issue. I'm just go through it quickly and show you some of the sample code that ChatGPT gave me. The final point is the solution of overfitting. As I said, you need to check deeply about each model configuration and to see for cross-validation, regularization, and hyperparameter tuning could be suitable for resolve this issue. About cross-validation, it is to get a better estimate of the model's performance. I think the more common approach of the complicated models is to introduce regularization and hyperparameter tuning. Now let's go back to the code. So basically, in order to run code, you need to install some packages about pandas, numpy, skitlearn, matplotlib, and seaborn. These are very common libraries. Then about Kaggle, I want to mention to you, if you want to use a Kaggle package, you always need to have the active API so you can download directly. I did not put much time to configure this part, but I leave it here just to remind you that there is a possibility to download the dataset directly through your code, but you need API key configuration. Then Plotly is for actively or dynamically display my data, all the different metrics that I need to evaluate the data and model. MP format is actually part of the package that will interact with Plotly, but I did not get a successful result, but I leave it here. So whenever the system says error about this package, try to install it, reinstall it. If it does not work, check documentation. So about the several steps before the final code, of course, I interact with the large language model. I try to teach it to find the very detailed problem to refine the model. For example, I already have the structure, I have some code written, but ChatGPT cannot recognize the necessity to transform the numerical data or make certain categorical variables as dummy variable. So it is an iterative process when you talk to large language model to refine the code. But in general, these, I would say, quite simple models about regarding the model design, they are quite simple. The zero shots or the accuracy of writing the code with a large language model will actually help you to improve the efficiency of writing the code. Okay, let's go on. So first of all, we need to read the data. Okay, about the first two lines, if you do not have the Kaggle API, usually it does not work. So I actually manually downloaded this dataset and save it in the data folder here. So I use Panda to directly read the dataset, of course. Then I prepare the X variable and a Y variable based on my need, and also to transform the numerical variable, categorical variable as I need. So basically, you need to pay attention to all of these details. You need to understand your data set. So you can work better on it. Then this part about showing the correlation matrix is not 100% necessary, but if you want to visualize the correlation between different variables, I suggest you to do it. But remember here about the sex, education, and marriage, because they are categorical variable, putting them here is not 100% necessary. I suggest you to delete it. But if you put here, just don't refer to it as main issues or the main influence to the dataset or to the model in a numerical sense, I mean. Then we can see here, we actually split the data to training data and test data. Okay, this is a common practice. Then define the evaluate model function. Actually, it will record the runtime, which I personally would like to check every time to see each model consumes how much runtime, which will refer to the compute consumed. And of course, we are going to use a different function to actually to train and to get the different metrics which we are going to display later. So each of the functions, each of the equations will actually help me do that. For example, this one is going to help me get the train accuracy matrix, so I can display later. And in the later part, of course, ChatGPT was helping me to add such if condition passage to actually capture some of the information I need, like number of parameters, coefficiency number. The size means that how many coefficients used in the model, how many layers, how many features, okay, and to actually summarize these information so I can use later. So eventually it will return all these metrics so I can compare later. So about the model definition part, because we already imported different packages, actually most of the models are ready. I mean ready because we already have these packages. We can easily write in the code to implement them. As I said, like the different parameters in different function, you are free to change them. Or if you want to do further experiments, you can use a function to change it. For example, each time you change it by 10 units or 1 unit of each parameter you are setting here to see the difference. Okay, sometimes I do it just to check the different model performance. Then the results will be will be collected. So for the later comparison, and the results are going to be saved in this data frame. So in the later part about the results data frame, I use different strategy to plot them. For example, this first one is quite intuitive plotting. I observe that for most of the model, they have the overfitting problem because training accuracy is higher than test accuracy. And I can also see that although the neural network has very large parameter count and also consumes the highest compute, local compute resources, but its performance is not very, very high compared to other models. And we can also see here mean squared error, the metrics to see the diversion. I would say the diversion from the actual value to the model value. And we can see that For some models, it does not have such matrix, so the system cannot produce it. But whenever we see if the test MSE is higher than the train MSE, this is also a way to see that the model is overfitting. To the later part, of course, this one was the same graph. Of course, when you try to visualize it, you can change the size of the graph, but at this moment, I cannot resolve the issue of the display because you see gradient boosting. The display of the chart was not very good because you see the I think is the test accuracy bar is quite out of range. But do not worry if you meet some problem like this. I'm going to show you some solution like Ploty library. And here I did introduce the 3D plotting of the results to see the test accuracy, which I care a lot about, and the runtime, and in the z-axis we see the mean squared error. From here, it's not very easily to observe, so I would recommend you to use Ploty. So first of all, let's try to display the 3D graph of the different metrics. If we run the code, I'm going to see here. Okay, so actually it jumps into this HTML file. I think it's very easy to visualize, and you can change the different data you want to visualize. For example, I want to see train accuracy and test accuracy. Okay, so I have this pair of comparison about the train MSE and the test MSE. Okay, so in a dynamic way, it will help you to visualize better. However, I did not change much of the code. The original code generated by ChatGPT stacked them together. I would suggest you to change them to make them separate because they do not have a stacking relationship. But if you are going to see only pairwise comparison, this version is enough. So let's see here. This is going to show us the runtime, test accuracy, mean square error, the 3D plot. And here we go. You can see here, when we actually rotate the 3D display, you can see the position of different models. Of course, if we only care about the runtime, we can see here we have a neural network is way further away than the other models. And here, if we only care about the mean square error, you can see decision tree actually has the highest mean square error. I think this is training mean square error. You can check the code and change a variable to compare. Now about the complexity summary of the models. These are generated by ChatGPT. I think most of them make sense. The only thing I'm not sure about is about the equation for complexity. I think it is utilizing the number of parameters and the different variables to display. But about interpretability, it's intuitive for different model. Of course, we find it easier to interpret or harder to interpret. As I said, the simpler it is the model, the easier you can interpret them. About the last one, let's see the chart. Okay, actually, this one is about runtime, number of parameters, test accuracy. Okay, so if we look at here in this way, the test accuracy does not have a significant relationship with number of parameters, because you see here in the group where we have the highest test accuracy, actually most of the models have less number of parameters than neural network. Okay, and we can also see in this way, in the runtime sense, neural network is the slowest one. So this is part of the reason that when we train a huge neural network, it will cost a lot of compute, and most likely they are not suitable to run on local machines. Then about the runtime and test accuracy, see it in this way. Just 1 second. So most of the models has a similar runtime consumption, but about the test accuracy, it don't change much. But you can see here, gradient method, gradient boosting, has the highest test accuracy, and the runtime is quite reasonable. By reasonable, I mean because we have a relatively small data set. When you have a huge data set, you need to introduce different strategy to handle such huge data sets. I wish in the future we could discuss some of the implementation of the methodology to handle large data sets. Now about the final part, as I mentioned before, overfitting is always an issue. I would suggest you to pay attention to it, and if you want to address it, use different methodologies, do more tests to understand which one is better to actually. I think models are like animals which are not contained, because if you are not contained, you may go to a very long range and you are not confined by your target. Regularization is like a way to actually make sure that the animals know their target, know their prey, so they could focus their energy to that target, to that objective. So this part I'm not going to go any deeper. As you can see here, if you interact with the language model or with your domain knowledge, you can design further code to actually test the different modification, either by the hyperparameter or some regularization terms to make the models work better. So today's introduction or a sharing of experience, I'm going to stop here. So just a quick wrap up. I would suggest you to test different models to deeper the understanding of the model's compute consumption, accuracy, overfitting problem, and how to um, test them repeatedly and to use them in your real world data set to actually see if they work well. And about the overfitting issue, remember, I'm not introducing you now because I don't want to complicate the focus of this video, but I do recommend you to pay great attention to it. It will make your model more balanced if you address the overfitting issue properly. Okay, so thank you very much for the attention. If you like my video, please share it. Please give it a thumb up. And if you like my channel, please subscribe. If you want to discuss anything you like, you have any suggestion, leave a comment. And I'm going to see you next time. Thank you very much. Bye bye.